Hi my dear friends. Today we are discusses about basic terms and definitions of welding, technology for beginners. I am Yogeshwaran, welding inspector. Brazing is a metal joining process in which two or more metal items are joined together by melting and flowing a filler metal into the joint, the filler metal having a lower melting point than the parent metal. Adjacent surfaces of the part to be joined by capillary attraction. In the melting point of the filler metal is above 450 degrees Celsius, but always below the melting temperature of the parent materials. Welding, to join metals, by applying heat, sometimes with pressure and sometimes with an intermediate or filler metal having a high melting point. Welding joint. A welding joint is a point or edge where two or more pieces of metal or plastic are joined together. They are formed according to a particular geometry. 5 types of joints referred to by the American Welding Society: butt, corner, edge, lap, and T. Weld, the union of two metal parts by welding. Butt joint, a joint formed by two pieces of metal united end to end without overlapping. T joint, a right angle joint, one in metal, making the shape of the letter T. Corner joint, being one of the most popular welds in the sheet metal industry. The corner welding joint is used on the outer edge of the piece. This weld is a type of joint that comes together at right angles between two metal parts to form an L. These are common in the construction of boxes, box frames and similar fabrications. Edge joint, being a groove type weld. Edge joints, the pieces are set side by side and welded on the same edge. 4 heavier applications. Filler metal is added to melt or fuse the edge completely and to reinforce the plate. Lap joint. A lap joint is formed when two pieces are placed in an overlapping pattern on top of each other. Also considered a fillet type, the weld can be made on one or both sides. Cruciform joint. A cruciform joint is a specific joint in which 4 spaces are created by the welding of 3 plates of metal at right angles. Cruciform joints suffer fatigue when subjected to continuously varying loads. Autogenous welding, a fusion welding process using heat without the addition of filler metal to join two pieces of the same metal. Example: tug welding, plasma, electron beam, laser or oxy-fuel gas welding. Slot weld, a weld between two members, one containing an elongated hole through which the other member is exposed. The hole is completely or partially filled with weld metal, thereby joining the two members. One end of the hole may be open. Plug weld, a weld made by filling a hole in one component of a workpiece with filler metal so as to join it to the surface of an overlapping component exposed through the hole. The hole can circular or oval. Full penetration weld, a weld joint where the weld metal fully penetrates the joint with complete root fusion. The preferred term is complete joint penetration, CJP. Partial penetration weld, a welded joint without full penetration. The preferred term is partial joint penetration, PJP. Homogeneous joint, welded joint in which the weld metal and parent material have no significant differences in mechanical properties and or chemical composition. Heterogeneous joint, welded joint, in which the weld metal and parent material have significant differences in mechanical properties and or chemical composition. Dissimilar/transition joint, welded joint in which the parent materials have significant difference in mechanical properties and or chemical composition. Parent metal, metal to be joined or surfaced by welding, braze welding or brazing. Filler, metal, metal added during welding, braze welding, brazing or surfacing. Weld metal, all metal melted during the making of a weld and retained in the weld. Heat affected zone, HAZ, the part of the parent metal metallurgically affected by the heat of welding or thermal cutting but not melted. Fusion line, boundary between the weld metal and the HAZ, in a fusion weld. Weld zone, zone containing the weld metal and the HAZ. Weld face, the surface of a fusion weld exposed on the side from which the weld has been made. Root zone, on the side of the first run furthest from the welder. Toe, boundary between the weld face and the parent metal or between runs. This is a very important feature of a weld, since toes are points of high stress concentration and often are initiation points for different types of cracks, egg fatigue and cold cracks. To reduce the stress, concentration, toes must blend smoothly into the parent metal surface. Excess weld metal lying outside the plane joining the toes. Other non-standard terms for this feature are reinforcement and overfill. Angle of bevel, the angle at which the edge of a component is prepared for making a weld. Included angle, the angle between the planes of the fusion face of parts to be welded. For single and double V or U, this angle is twice the bevel angle. In the case of single or double bevel, single or double J bevel, the included angle is equal to the bevel angle. Root face, the portion of a fusion face at the root that is not beveled or grooved. Its value depends on the welding process used. It has a value of 1 to 2 mm for common welding processes. Root gap, the minimum distance at any cross-section between edges. It's generally 1 to 4 mm. Root radius, the radius of curved portion of the fusion face in component prepared for single or double J or U weld. Land, straight portion of a fusion face between the root face and the radius part of a J or U preparation can be 0, usually present in weld preparations for MIG welding of aluminum alloys. Groove weld, here the two sides to be welded require full penetration in order to achieve a strong connection. The gray area in the photo shows the place where the weld is performed. Although it's not shown, you may recall from the anatomy section that both sides of the base metal must be fused together, creating a fusion zone, with reinforcement at the top and bottom. The drawing does show that both sides are beveled to widen the gap, and that an opening is left at the bottom of the plates to be joined. This makes for a nice pocket, or groove, to hold the molten metal as it gets deposited. V-joints, single butt welds are similar to a bevel joint, but instead of only one side having the beveled edge, both sides of the weld joint are beveled. In thick metals, and when welding can be performed from both sides of the workpiece, a double V-joint is used. When welding thicker metals, a double V-joint requires less filler material because there are two narrower V-joints compared to a wider single V-joint. Also, the double V-joint helps compensate for warping forces. With a single V-joint, stress tends to warp the piece in one direction when the V-joint is filled, but with a double V-joint, there are welds on both sides of the material, having opposing stresses, straightening the material. U-joints, single U-butt welds are welds that have both edges of the weld surface shaped like a J, but once they come together, they form a U. Double U-joints have a U formation on both the top and bottom of the prepared joint. U-joints are the most expensive edge to prepare and weld. They are usually used on thick base metals where a V-groove would be at such an extreme angle that it would cost too much to fill. J-joints, single J-butt welds are when one piece of the weld is in the shape of a J that easily accepts filler material and the other piece is square. Our J-groove is formed either with special cutting machinery or by grinding the joint edge into the form of a J. Although a J-groove is more difficult and costly to prepare than a V-groove, a single J-groove on metal between 1/2 inch and 3/4 inch thick provides a stronger weld that requires less filler material. Double J-butt welds have one piece that has a J shape from both directions and the other piece is square. Fillet weld. Fillet welding refers to the process of joining two pieces of metal together, whether they be perpendicular or at an angle. These welds are commonly referred to as T-joints, which are two pieces of metal perpendicular to each other, or lap joints, which are two pieces of metal that overlap and are welded at the edges. The weld is aesthetically triangular in shape and may have a concave, flat or convex surface depending on the welder's technique. Welders use fillet welds when connecting flanges to pipes, welding cross-sections of infrastructure, and when fastening metal by bolts isn't strong enough and wear off easily. There are 5 pieces to each fillet weld known as the root, toe, face, leg and throat. The root of the weld is the part of deepest penetration, which is the opposite angle of the hypotenuse. The toes of the weld are essentially the edges or the points of the hypotenuse. The face of the weld is the outer visual or hypotenuse that you see when looking at a fillet weld. The legs are the opposite and adjacent sides to the triangular fillet weld. The leg length is usually designated as the size of the weld. The throat of the weld is the distance from the center of the face to the root of the weld. Typically, the depth of the throat should be at least as thick as the thickness of metal you are welding.